Hello everyone, welcome to Engineers Ireland. We're starting today to cover the Junior Cert Honours Maths course. Now we will mainly cover the traditional Honours Maths course and start to feed in later on, we'll start to feed in the project maths. The traditional course has lots of advantages insofar as that it's very clear on basic concepts. The reason I mention that is I'm a firm believer in the basic concepts. If you guys get the basic concepts right, you will be easily able to step your way through much more complicated mathematics. So what are basic concepts? The first thing is to remove something that you believe is true, to get rid of it and replace it with something that's right. That's a basic concept. And the first one of those that you need to get rid of is the belief that mathematics is difficult. The best way of understanding this is whatever problem you're thinking of and you're saying that the mathematics is difficult in it, have you any idea how hard it would be to solve that problem without mathematics? Mathematics is not there to make life difficult. It's the big purpose of the application of mathematics is to make things simple. Okay, what are the simple things that we normally think of that automatically come into mathematics? And here now we're moving into just how we think that mathematics should be taught. You yourself, in how you think, know instinctively your mathematics. You couldn't cross a street and have to deal with the opening up of spaces between cars and the shutting down of other spaces by somebody speeding or moving quicker than other cars and having to look at both directions. You couldn't cross that road without doing really detailed mathematics. And yet I don't remember hearing people talking about how difficult it was to do the mathematics to cross a road, and yet you give somebody a very simple little problem from standard mathematics and they're off complaining that it's difficult. What are the type of things that we normally do? We look at differences. The difference between €6.50 and €5 is €1.50. That concept is absolutely central to geometry of the line, because at the end of the day, if we start to look at and this is, remember, an introductory course, so I'll bounce around in lots of little sections and we'll obviously get back to the line on each of the other ones that I'll talk about, but at the moment we're just introducing how we look on things. So here is a straight line. Here's what we call the x, and here's the y-axis. We're going to look at differences, because for a straight line, that's really what you need to understand to be able to describe this line. If we are here on the line and we want to understand what this line is, what we do is we take a step 1 unit across in that direction. We move across 1 step, 1 unit, in the x increasing direction, and having reached this point here, straight across, you look up or you look down to see where the line is. In this case it's above. This amount that it's above, let's say we've stepped across to the right hand side from having been standing on the line, we've stepped across 1 unit in the x, and we will say that it's gone up 1 unit. The slope of that line is 1. If on the other hand we had a line like this, we take 1 unit across in the x and we will just say that it moved up 2 this time, that the change or the difference in the y value between what it was down here and what it is up here, if the y has increased by 2, the slope here is 2. That's all slope is. It's telling you a difference. For a change, a positive change of 1 unit in the x, what happens to the y? That's all slope is. In both of those cases, y got bigger, so the slope is a positive, it's a plus. Clearly. If we're over here, and we're standing on the x-axis, and we take 1 unit of a step across, we might be going for, from example, I know it won't look like it, but that's not a major problem. We might be going from x equal to 3 across to x equal to 4. 1 unit is what we're crossing here. And now we'll say, aha, this thing dropped 1.5. It's gone down 1.5, so it's minus 1.5. The y value dropped from its value here down to this value, and the difference between those two y values is minus 1.5, the slope here. Then, this is one of the nice things about maths. We find it possible in mathematics, in considering 1 or 2 examples, once we consider them in a consistent and proper way, that it's possible to apply what we've learned into a general equation that will apply to everything. So here we go. We've called this axis x, that axis y, and we'll move it away from that one. We can now say that for, if you look at any of these examples we've over here, for every step of 1 in the x-axis, the y is going to change by the slope amount. So here, move across 1 step. That amount here is slope, which we normally call m. What you have to now understand is that if I moved across 5 units in the x, because it's a straight line we're dealing with, this is going to be 5m, 5 times the slope. And say 5, what is that? That's the amount the x has changed, isn't it? We're actually very close to being able to develop the simple equation for a straight line without really having done anything other than speaking in terms of difference. So, if we're now saying to ourselves, starting x here, and we're on the line there, so we're starting at x equals 0, and we're saying we're going to step all the way across. How far? We'll step x in distance. We're now going to look at how much did the y change by. We can answer that immediately. The y has changed. That vertical height here is going to be m multiplied by x. X is the amount we've moved across. That's handy. But what's its actual height? The height here. What is this value? Well, we've already worked out this bit of it, because it moved across x. We're saying this is mx. And there's another little bit that we have to look at. It's this bit down here. and this is the second important thing to understand about making life easy in mathematics, we name things. You may have 30 acquaintances. How you deal with those acquaintances would be very difficult if they didn't have names. It's the exact same thing with mathematics. We give names to things to make life easy. This little bit here that we're looking at, that little height, we can call it C. It's just a name, constant. First letter of constant is C. So now I can tell you this height here. That height is going to be, the y is going to be equal to the mx plus c. I know you know this stuff already. That's not the point. This is just an introductory talk, and the idea is just to get your mind back into thinking about mathematics, and also to let you understand that anything we're doing is standard thinking, your own standard thinking. That's what we're hoping to be able to put across in the next 9 or so months. We're hoping to get you to recognize that what you call your thinking is in reality, or logical thinking that is in reality proper mathematics. And if you learn to use your own thinking in the subject called mathematics, you'll get very good at it. We've done 2 things here. We've named something. You will find that concept will crop up a lot in mathematics, because naming things simplifies things. I could write, well, let's say for argument's sake, we will say to you, three x to the 5 minus x to the 5. You could be going, oh my god, x to the 5. What is that? Don't worry about it. You can call it an apple. I call things, I rename them into things that I'm familiar with. If we call that an apple, x5, every place I see x to the power of 5, I can call it an apple. And all we have is 3 apples minus an apple. And we know that's 2 apples. So now we step back from our name again, and we're saying, okay, what was it that I was calling an apple? X to the 5. So 3x to the power of 5 minus an x to the power of 5 is 2x to the power of 5. But it sounds a lot easier to say 3 apples minus an apple is 2 apples. I don't care if you call them Fred or Joanne. They're just names. Whatever name suits, and that makes it easy for your mind to think your way through it, put it into that name in your mind. I have gone to the bother of writing down 3 apples minus an apple equals 2 apples, but that's the bit you would do in your mind, the bit that you would keep in your mind to keep life simple and easy and your thinking clear. You would have gone straight from 3x to the 5 minus x to the 5 is 2x to the 5. But in your mind you could have the extra step if you need it. The little example we've given here is a terribly simple one. And the likelihood is that you looking at this right now will be saying, that's so simple, I don't need to do it. If you're saying that, you're missing the point. Because this is the next thing that you need to understand. When you're learning a subject, any subject, and in this case mathematics, you will be given some examples and even some exercises that are extremely simple. The solution of them is not a problem. But you're not given them so that you will get the answer to the thing. You're given those problems or those examples so that your mind will get familiar to using whatever the concept was. I'm saying 3 apples minus an apple for an equation that is very easy for you to teach you the principle of changing names. And when you get that principle on simple problems, you can then go and apply it to more complicated problems. That gives you a principle on how you should learn your mathematics. The start of almost every chapter is simple, and we have a tendency of rushing through it, and then about halfway through the chapter we start to slow down. Things are getting a bit more complicated for us, and towards the end of a chapter we are barely moving through it. The reason that's happened is not because the mathematics is hard, it's because we miss the point of how a chapter is constructed. The start of a chapter is simple because it's giving you the basic concepts. Your job is to slow down at the start of a chapter. As soon as you're learning anything new, you do not rush through it. You take lots of time at the start of a chapter. You spend a lot of time carefully going through the simple examples because they're teaching you principles or giving you a concept in relation to, for example, the use of giving a name to something to make the thinking simple. Haven't gotten your basics, you can then actually go quicker or at a faster pace through the middle of the chapter. And generally, if you've gone slowly at the start, you find by the time you're at the end of a chapter, the end of a section, you can go at a faster pace than most other people, because towards the end of a chapter most other people are still struggling with concepts and basic technique. So that's your principle. Start at a slow, patient pace, and then you'll find you can speed up. For a long time I've played guitar, and I'm sure a lot of you guys out there play some instrument, or you play sport. It could be rugby, hurling, which is one of the great gifts to people, is hurling. Beautiful sport. You can pick any of those and you find the same principle applies. To stand out on a hurling pitch with a hurl in your hand is to basically declare that you know the basic principles, knowing how to pick a ball off the ground without having to learn it on the pitch. It would be very stupid if you told all the guys, hang on a second, stop there, I want to figure out how to get the ball off the ground without picking it up with my hand, just using the stick, the hurley. Well, you would find that you'd be off the team very fast. This is a ludicrous discussion, I accept that, but the principle is the same. You learn the basics, and you learn them slowly, very slow pace, because what you learn from playing the guitar or any other instrument or hurling is that if you get the basics and you learn to do them slowly, you can then speed up. The old rule on playing guitar is if you want to learn how to play a piece of music fast, you play it slow to begin with, you perfect it, and then you build speed into it. You will find in each of the chapters that we're going to be covering in your maths, I will start very slowly. I'll go through the basic principles and then more than likely start to speed up, and then probably pop in one or two little ideas that helps later on in the chapter. But when we're halfway through any given chapter or section, if you're finding it hard work, it means you didn't pay enough attention at the beginning. Now, here's a few more concepts that haven't to do with mathematics. It has to do with everything, whether it's playing the guitar, hurling, mathematics, learning any other subject. We make mistakes. We make a lot of them when we're learning something. That's not a problem. The problem is not learning from mistakes. So how does this work in relation to your subjects? And how will it work in relation to how you should learn your mathematics? You're given problems, given exercises to practice. You practice so that you find out the things that you're not as clear on and where you can make mistakes. And having practiced like that, you will overcome the things that were a problem for you. If I explain a concept to you, you can say that you understand it. If we spend the next 9 months, and if what happens is that I explain things and you listen and understand them, and now 9 months or so from this date, you're standing outside your junior cert maths exam hall, you're not going to get an A1. Even though you may understand everything in the maths course, you won't get an A1. Because you'll be too slow. You need to turn understanding into knowing. You ever notice how cocky and confident you are when you get to say, yeah, I know that? There's no doubt in your mind whatsoever. I know it. It's different saying, yeah, I understand that. Your job, sorry, let me restart this. My job is to explain things to you to a point where you should be able to understand them. Your job, your half of this contract that we are going to have, is to practice in order to turn understanding into knowing. If you do that, and you are now standing outside the exam hall for your junior cert maths, and you're standing out there saying, I know this course. First off, you'll have no exam nerves, and secondly, 2.5 hours, hey, you'll be out long ahead of that, because in having changed understanding into knowing, you'll have become fast. You will have more than enough time in 2.5 hours to patiently go through your questions without rushing, and have time left over at the end to go back and look at things. It's all doable. The Department of Education sets standards that it wishes all of you guys to reach. It does not set impossible standards. If you find yourself going around and saying, oh, this is too difficult, you're either playing a mind game with your parents and family, or you have deluded yourself. But most likely you're not studying. And in study, there are two major elements. One is learning something to understand it, and the other is practicing it until you know it. And you will find as we get later into this year that we will go through most, and certainly all, of the interesting questions that have come up in Junior Cert Honours Mathematics for maybe 10-15 years. It would be a serious surprise to me if these were outside your ability to understand. It would be a terrible mistake on your behalf in having looked at these and saying, yeah, I understand them, if you left it at that, because you're committing the mistake of thinking to understand it is enough. You must practice. And if later on you find that I'm going a bit too quick for you, don't blame me, blame yourself. If you have to blame anybody, but better still, recognize that if you're finding it difficult, you need to go back and practice. I know that the vast majority of you can do very well. I can know this without knowing any of you. And the reason for it is, every other year, for generations back, students have got through their Junior Cert Honours Mathematics. And about the same percentage will have got A's and B's and have performed well. The odd thing, though, is that they aren't as a group, they aren't the most intelligent necessarily. You will find very intelligent people will get A1s, yes. But most of them that get A1s, 2s and high B results are not the most gifted. They're the most determined. You have a number of decisions to make. Only you can make them. I can explain things, that's all I can do. Everything else is down to you. Make your mind up and practice. If you drive for this, if you really work at it, I can promise you one thing, and that is standing at the door of your Junior Cert Honours Mathematics exam. You will already be proud of yourself, because you know you've prepared yourself to be there, and you should be able to walk in without any stress or pressure, because you should be standing there just waiting to perform. I don't know, whatever activity it is that you'd have, such as sport or music or whatever. You think in terms of the mathematics, you think in terms of that. Let's say it's rugby. If you have put in the hours of training, you've put in the hours of listening to the tactics, applying the tactics in countless training sessions, and you are now running out with the team, you expect to win. You believe you deserve to win because you've worked. It should be the exact same for your maths or any of your other subjects. You should be going in there to compete. You should be going in there to show what you've learnt. And you only can do that if you've learnt it. And there's two aspects to it. Understand first. Through practice you turn understanding into knowing. Okay, last lesson, and then we'll finish all this yappy bit, and next week we'll get down to covering it chapter by chapter. Here's the last thing. Can you remember right now the equation for the distance between 2 points? Some of you, I'm sure, can. Some of you, I'm sure, cannot. So what has just happened? If you understand what's happened, you are more capable of getting a better result in your Junior Cert. There should be 3 groups of you now. Those that never learnt it to begin with and had no chance at all of recalling it. Then there should be the group that did learn it and didn't and couldn't recall it. And the third group are those who learnt it and could recall it. You will notice the operative word and the significant thing that divides or separates out the last 2 groups is recall. We make a mistake, by the way. We often say, I have a bad memory. That's nonsense. We've got great memories. The simple proof is, try to forget something. That's when you know how good a memory you have. So, what do we really mean when we say I have a bad memory? We really mean, I can't recall something. Now, recall is to bring something into the light of your mind. In other words, into the conscious part of your mind. 1 and 1 is 2. I didn't have to sit down and calculate out that it's 2 because as a small kid I learnt it off. I just simply recalled that the answer is 2. You can't recall something you never put in. So, for you, throughout the year, not only in maths but your other subjects, you should be strengthening your ability to put something in your mind and recall it. When you have finished with a page of your mathematics and you're turned on to the next page or whatever else it is, stop yourself and ask yourself, assuming you had an equation in the previous one, what was that equation? Every time you ask that, you're demanding from your mind to recall it. If the mind hadn't paid attention, it can't recall. You go straight back and you look at it, and this time the mind will look at it because it hates being found out. None of us like not being able to do something. But having looked at it carefully, it has now placed it in the mind, in storage. We have to practice being able to take it out of storage and quickly, as quick as 1 and 1 is 2. That practice works for everything from quotes from Shakespeare into formulas in mathematics or anything else that you're dealing with. Constantly interrogate the information that you've placed in your mind. Interrogate your mind. Demand its recall. You will strengthen an ability that will speed you up hugely and give you a lot of confidence. I know most of the equations you need are in the logbooks. Any idea how slow you would be if you had to be flicking around pages in the logbooks in your exam? And time is something you don't have a lot of if you're slow. And you'll be slow if you haven't learnt well. You will have more than enough time if you've speeded up. Strengthening recall. Strengthening your ability for your mind to see something, recognize it. And having practiced, turning understanding into knowing will make you very fast. Now, these are just general chats in relation to the type of thing you will hear me saying right throughout the year. The likelihood is you'll get fed up with some of these things, but other ones may eventually find, we'll say, you in a position where you'd say, okay, right, I'll try that. And if you try it and you find it useful, then it'll be very hard for anybody to stop you using it. But in the meantime, you've got all my basic little principles. I will teach you, hopefully, to the point where you understand it. The responsibility after that is yours. You turn understanding into knowing. And while you're involved in that, you constantly interrogate your mind to recall the equations and methods that you need to strengthen recall. You do that. You will be proud of yourself. And you will do well. Okay. I will see you next week when we really start the course, okay? And I would hope that it'll be fun. You will find that I'll bring in a lot of stuff that isn't on your course, but mainly because it's interesting. And yes, mathematics is interesting. And I will more than likely talk about a lot of, or several of the really important mathematicians that has led us to the point where we have the mathematics we have now, that has made our life easy, not difficult. Okay? I wish you well throughout the year. Bye now.